Hi, this is Mrs. LaBarbera. This is Regents Physics, Chapter 2, Video 10. Today's topic is Newton's laws. The objective is to use Newton's laws to analyze Newton's first and second law says acceleration is F net equals so I combined here. This is because when F net equals to 0, acceleration equals to 0. That's regarding the second law is really says when F net is not 0, then acceleration is directly proportional to the net force and inversely proportional to the mass. In this equation, net force is the vector sum of all forces. Newton's third law says force comes in action-reaction pairs. Question: why does all free-falling object falls at the same rate of acceleration is 9.81 meters per second squared? This is really can be proved from Newton's second law. Acceleration is a net force over mass. Now, when object is in free falling, the net force is just mg. That's the only force acting on the object. Then you substitute here, you get acceleration equals to g because mass cancels out. So the ratio of force to mass is the same for all objects involving free fall because mass cancels out. That's why all objects falls the same rate. Elephant and a little mouse, they all falls the same rate because their gravity equals to mg and m cancels out. So here is an animation showing an elephant and a mouse in free fall. So these are a series of questions asking you if they are true or false. I want you to read each single one, come up with your answer, then you can compare. Question. What happens when you fall with the air resistance? As an object falls through air, it usually encounters some degrees of air resistance. Air resistance is the result of collisions of the object's leading surface with air molecules. The two most common factors that have a direct effect upon the amount of air resistance are the speed and the cross-sectional area. For speed, the increased speed results in increased cross-sectional area results in increasing amount of air resistance. That's why for skydivers, you need increasing speed leads to an increase in the amount of air resistance. Eventually, the force of air resistance becomes large enough to balance the force of gravity. At this instant in time, the net force is 0. So the velocity is your constant velocity. That at that moment, acceleration equals to 0. When falling with air resistance, more massive object will fall faster. Why is that? That's because more massive object will have a large gravity acting on it, and this large gravity will accelerate to a higher terminal velocity. Consider an elephant and a feather falls. So this is after first second. So both feather and elephant have experienced air resistance, but air resistance has such a smaller effect on resistance has relatively large effect on the feather because of its small gravity. After t equals to 2 seconds, the feather has reached the terminal velocity because air resistance balanced the gravity. On the other hand, it still hardly have any effect on the elephant. Even after 5 seconds, the elephant is still have net force going downward, so it's still accelerating downward. On the other hand, the feather has been moving at a constant velocity for a while. Let's take a look at this example. Consider the dragster's motion below. Speedometer rating and the forward proportion force are shown. The top speed is 120 miles per hour. Draw F air force arrow on each diagram to illustrate how the amount of air resistance changes during the course of its motion. So as it moves at 30 miles per hour, it will experience air resistance is opposite of your propulsion force. As you increase your speed, air resistance increases. When you reach the 120 miles per hour, the air resistance equals to propulsion force. This is because 120 miles per hour is your terminal speed. Now finally, when you withdraw your propulsion force, the only force is an animation of the diagram below. A free body diagram shows the forces acting upon equipment included are shown. For each case, use the diagram to determine the net force and acceleration of the skydiver. So in the first case, the net force is just 833 newtons. The skydiver is in free fall, and we know skydiver's mass is 85 kilograms. We know in order to find acceleration, we find net force and divide by mass. So the first case, diver's net force is just gravity, 833 newtons, and he's in free fall, 9.81 meters per second squared. In diagram 2, the net force is the difference between the two forces because net force is a vector sum. 833 minus 350 or 483 newtons downward. So acceleration is downward. 483 divided by 85. Diagram C, you'll have a net force 133 newtons downward. So acceleration is 1.6 Newton meters per second squared down. Diagram D, you'll have net force is 0. So therefore acceleration equals 0. Diagram D is when you reach terminal velocity. Next, let's talk about two-body problems. What is two-body problem? Two-body problems obviously involves two objects, such as this. Here is an example, another example, and another example. So this all examples involving two objects. So there are two ways to analyze two-body problems. One is a system analysis. When do we do a system analysis? When we have to find acceleration. When we have to find acceleration for any object, because any object, they accelerate as their acceleration are the same as the whole system's acceleration. So for example, here's 2 kilograms, 4 kilograms. We simply combine as you're pushing one object with 6 kilograms. Here is 3 and 5. You combine them into 8 kilograms. So there's just one force pulling a bigger object with 8 kilograms. Even with pulleys, you can combine the two masses into 4 kilograms. Let's do an example. A 5 kilogram and 8 kilogram box are touching each other. A 45 Newton horizontal rightward force is applied to the 5 kilogram box in order to accelerate both boxes across the floor. Ignore friction force determine acceleration. See, when you have to find acceleration, you treat it as one object. So this as one, it would be 15 kilograms. What experienced a net force of 45 newtons because gravity and normal force cancels out. So net force is 45 kilograms, 45 newtons, and the total mass shows a horizontal 12 Newton force being applied to two blocks, A and B. initially at rest on a horizontal frictionless surface. Block A has a mass of 1 kilogram and block B has a mass of 2 kilogram. What is the magnitude of the acceleration of block B? So acceleration of block B is the same as block A is the same as the whole system, A and B. So again, to find acceleration, we combine the two together. Combine two, total mass is 3. Here is a net force acting on both blocks. Acceleration is 4 meters per second squared. As you can see, this answer does not have direction because they didn't ask direction. They only asked the magnitude. Sometimes we have to do individual object analysis. When do we do that? When you have to find the force between the objects. So here's a blue box and a yellow box. You need to ask what are the forces acting on the blue box and what are the forces. You see the yellow box has one advantage over blue box is yellow box has one less force. So it's a little bit easier to look at the yellow box. Example. So 5 kilograms and 10 kilograms are touching each other. The 45 Newton horizontal rightward force is applied to 5 kilogram box in order to accelerate both boxes across the floor. Ignore the friction. We have determined the acceleration of the system is 3 meters per second squared before, right? Determine the force acting between the box. So this is asking the force between, we have to separate it. So let's do the big box first. Why do we do the big box? Because big box has less force. So here are the forces acting on the big box. Gravity and normal force, they cancels out. And this applied force is really the force between the two boxes. So the net force is on the big box, F applied is the force between the boxes. That's F net equals MA. The big box's mass is 10 and it's accelerating at 3, so you have 30 newtons. Another way is to analyze the force on the smaller box. So it's fine, except it's a little bit complicated because you have both forces in the horizontal direction. On the smaller box, you'll have applied force. This applied force is from your hand, that's 45 newtons. And this force to the left, and this applied force, those are action-reaction forces. They are acting on different bodies. One acting on the yellow box, one acting on the blue box. So this is the force between the boxes. So again, you can find the net force equals 45 minus F between the box equals MA. Yourself, the force between the box is 30 newtons. That's it for today. See you. Thanks for watching. See you next time.